We're at gotomath.com looking at some calculus problems. We're down here at related rates and we're in this section right here. And we're going to be looking at another one of these utility ladder problems. I don't believe it's exactly that one. And let's click over. Okay. With this time we have a 14-foot utility ladder leans up against a vertical wall, and when the base of the ladder is pulled away from the wall, the rate of change of the distance from the base to the wall is 3 feet per second. And what rate is the top of the ladder moving down the wall when the base is 3 feet from the wall? Round your answer to 2 decimal places. So let's move over to the classroom, and of course I've got a couple of these problems using the same picture here as one we just got through doing. So here's the ladder, all right, and the length of the ladder is 14. The length of the ladder is 14 feet. All right, so we know the length of the ladder. This ladder is sliding down this wall, okay, and this is the base, which is going off in this direction. Now, as the ladder slides down the wall, and the base is, I believe they said 3 feet from the wall, so we'll just label this as 3. So this is like the XY axis, where this is the origin here. All right. So what are some things that they actually gave us? They gave us dx over dt, and that is 3 feet per second. 3 feet per second. So it's sliding away from the wall at 3 feet per second. And we were asked to find the rate of which it's sliding down the wall. This rate here, okay, which is your dy over your dt. So this is actually what we need to find here, dy over dt. Now, there's something else we need to find, and that is actually this distance from here down to here. We need to find that distance because we're going to need that to plug that into the formula that we're going to use for finding dy over dt. Alright, and so, okay, so let's just go ahead and find that. Now this is 14 squared. X squared, x is 3. So 3 squared plus y squared. So we just want to solve for y in this problem. And right, take 3 squared to the other side, so you have 14 squared minus 3 squared. And I'm just going to go ahead and simplify all that for you, and we should get 187 under here. Now we want to go ahead and use the exact value, okay? Use the exact value. We don't want to do any approximation at this point here. All right. So there's our y. That would be the distance from here to here. Okay, that's going to be our distance, and of course it's in feet. All right. So let's go back up to this guy, and since we need to find dy over dt, we're going to go ahead and take the derivative of this with respect to t. So the derivative of r squared is 2r, but we want to write dr over dt, and then this is 2x dx over dt, and this is 2y dy over dt. All right. Now, one thing about dr over dt, that would be this guy right here. Is this distance actually changing? And that answer is no. This ladder is not getting smaller or larger. It remains constant at 14 feet. And so this is a constant, and therefore this is going to end up becoming a 0 because this is not changing, right? So 2 times r times 0 is just going to be 0. So we just have 0 on this side. All right, we got to watch out for that. Now this 2 and this 2 we can multiply through by a half and get rid of both these guys. X we said was 3. dx over dt is 3 feet per second. Plug that in right there. Y, which we calculated here, this is the square root of 187, and dy over dt is what we need to solve. That's what we're trying to find. So we'll go ahead, take this over, and we got to the left-hand side, and you notice that it's a negative. Okay, so we got -9, and then bring that diagonally down. Square root of 187, and that is going to be equal to dy over dt, and we'll go ahead and approximate that. That is going to be a negative 0.658 something, yada yada yada, but we'll go ahead and just round that to 0.66. Now remember, this is going to be feet per second, so you don't want to leave off your units, especially if we are using units. You don't want to leave them off. Now there's something I need to say here real quick. dy over dt, which we're saying is approximately negative 0.66, it's negative. And so because it's dy over dt, it's negative because this is actually, this sign right here tells us that this distance is actually decreasing. Okay, that the distance is decreasing. It gives us a direction. That's what this does. It gives us a direction. But if we were to say, you know, in one of the problems, it actually initially starts off, it tells us that, you know, it gives us a number like 1 foot per second, that this is, the rate is changing at 1 foot per second, but because it's decreasing, we have to consider it to be negative. Okay, so technically, or we could also say the rate at which this is changing, sliding down the wall is 0.66 feet per second. But because we're labeling it as dy over dt, we're going to label it here as a negative 0.66. All right, and so clicking in the answer here, that's what you're going to see. dy over dt is equal to negative 0.66 feet per second. All right, so remember, this tells us the direction. Anyway, okay, so where were we? We're in this section here, and we're under related rates. We'll go back to the actual web page here. Of course, this is, I don't know, this is the section here that we're in, and related rates is what we're doing. I think I've already mentioned that 3 times. And of course, we're at gotomath.com. So see you there. Bye.